Chapter 15, Sample Problem Number 10. Water is flowing through a pipe, filling it completely. The pipe narrows to half its diameter from one section to the next. A physics student makes the following comparison of the speed of water in the two sections. Since the diameter of the pipe has been cut in half, but the same amount of water has to get through in the smaller section, the speed of the water has to double. What, if anything, is wrong with this statement? If something is wrong, explain the error and correct it. If it's correct, explain how you know. So let's sketch this out a little bit. We have a pipe, and then it has, say, that as its diameter, and then it goes to half the diameter. So something like, almost like that. And we say that there is water flowing. And then the student alleges that there must be faster water because the same amount of water goes through, but the speed of the water has to double. And this is a mixed bag for the student. It is true that since the same amount of water has to get through the pipe in some fixed amount of time, but what is not true is that the diameter of the pipe is cut in half, that the speed of the water has to double. Because what we're really saying is, imagine you have some volume of water, which would be think of it as a disk of water, and that disk would have a volume, called volume 1, which is the area 1 times V1 delta T. And then after going through, we would have some amount of water here. And so we would have a smaller thing where that area is A2 and this is V2 delta T, this length is. And so the volume, we should say here, is V2, the new volume, capital V2, is the new area times the velocity times the time, because it's the area times the height, and the original volume was the original area times the speed times the time. And then the student is exactly right that these numbers have to be equal, that all of the water that was in the green bit has to still be in the purple bit. So we have something like the area times the velocity times the time is the area times the velocity times the time, but the time is the same amount of time, and so we get that the new velocity is the original velocity times the ratio of the new original area to the new area. And so far so good, and we agree with the student. But the problem is that the area of a circular disk is pi r squared, or 1/4 pi diameter squared. And so when we put that in here, we end up with the original velocity times the square of their ratio. And since the ratio is 1 over a half, we get that it's 4 times faster, not double. So here it should have been, has to quadruple. Because, and this is very easy to forget, it's going to depend on the square of linear distances.